Hang on guys, let's look at this problem right here. This question is asking polonium 218 decays exponentially. The decay rate is 23.1% per minute and can be modeled by dp by dt is equal to negative 0.231p. The first question is asking find an equation that satisfies the differential equation. Let p of 0 is equal to p0. Okay, now let's try the first problem. The first one is find an equation that satisfies this pattern, right? So when we express exponential decay, we express like this. Now let's see how we can bring this equation into this pattern. And here you can see this is a separable equation, so you can separate and integrate. So this is going to be dp. I'm copying this one down. So this is dp by dt negative 0.231 p, and if I separate the like terms, this is going to become 1 over p dp is equal to negative 0.231 dt. Okay, now we are going to integrate both sides. This is going to be integration and integration. This is going to become ln of p, and in the other side we are going to have negative 0.231 t, and also we are going to have a constant. So let's put c right here. And to get rid of this ln, we have to take e power. So let's take e power both sides. So this is going to be e power of ln p, and this is going to become e power of this one. Okay, and e power ln cancels each other, and we will end up with p. And in the other side, we are going to have e power of negative 0.231 t times e power constant, because when the power add, it's multiplied, right? So this is e power constant, and in the final expression we have to express like this, right? So, and also this p naught is basically a constant, so this e power constant is going to be equal to p naught. So we can write our final answer as p of t is equal to p naught e power negative 0.231 t, and that's going to be the answer for the first question. Now let's look at the second question. It's asking if 1000 grams of polonium is present at t is equal to 0, how much is present after 90 seconds? Now here we have to be careful, because in the question we had this one in terms of minute, because they are saying this is 23.1 per 23.1 percentage per minute. So here this is in second, so we have to convert this one into minute, and 90 second is equal to 1.5 minute. Here we are trying to find what's going to be the how much is present after 90 seconds. So we are trying to find p of 1.5. So we are going to apply in this equation, and before we do that we have to know what is p of 0 values, right? To find the p of 0, what we do is we put 0 like p of 0. P of 0 is p0, okay, and here instead of t we plug 0, because we are trying to find p of 0. So this is going to be p of 0 times, okay, p of 0 times p of 0 is 1000 grams. Let's write that one down, 1000 grams, and then e power negative 0.231 times 0, because time is 0, that's going to be equal to 1000. Okay, so this is our p0 value. Now let's go ahead and plug it in the equation. So in the equation we are going to have p, we are trying to find p of 1.5. P of 1.5 is going to be 1000 e power negative 0.231. Instead of t I'm going to plug 1.5, because we are trying to find after 90 seconds, that's 1.5 minutes. So this is 1.5, and if you calculate this one you will end up with 707.16 grams. So that's going to be the answer for the second question. Now let's look at the third part. It's asking what is the half-life of the polonium 218. Now half-life is basically how the time it takes to like decay half of this value. Initially we have 1000, we are trying to find half-life, so this is going to be 500. 500 is equal to 1000 e power negative 0.231. We are trying to find the t. That's our question, and if I bring this 1000 to this side, that's going to be 500 over 1000. That's going to become 1 over 2, and in the other side we are going to have e power negative 0.231 t, and to get rid of this e, we can take ln both sides. If we take ln both sides, this is going to become ln half, and in the other side we are going to have ln e power negative 0.231 t, and we can move this negative 0.231 t to the front side, and ln and e become 1. Ln and e is equal to 1, so this is going to be ln of half is equal to negative 0.231 t. Therefore t is going to be equal to ln of half divided by negative 0.231, and you can see that ln, if we have ln that is less than 1, that's going to be a negative, so negative over negative, that's going to make this one positive, and if you calculate this one, you will get approximately 3 minutes. And to calculate this half-life easily, like the shortcut method, you can use this formula: t is equal to ln of half divided by k, the constant value. And that's how we do this kind of problems. I hope constant value is this value, negative 0.231. You can see in the original equation, this is our k, and that's how we do that. I hope this helps. Thanks for watching.